we're going to talk about more single oxygen functional groups, but this one is a little bit different. So the other namings we said, hey, there's a suffix, you append them on the end. Not all naming's quite that nice, and there's an exception, they're rare, but I want you guys to know them, and that is ethers. So ether has the general formula ROR. So that oxygen is connected to two separate carbons. It interrupts chains of carbons. So this can be things like CH3OCH3, which, I mean, by moving that oxygen to the inside instead of having it at the end and be an OH, this is fundamentally different in its behavior. Ethanol, the alcohol, is a liquid at room temp and impairs mental judgment, makes people, reduces sobriety, gives good emotions for a while and then depression afterward, the usual alcohol things. Ether, on the other hand, is a gas at room temperature, this version. It will also affect your brain, but instead of the slight euphoria and then depression that ethanol causes, this just makes people high. Ether is actually, it's one of the inhalant drugs. It is used to actually be an anesthetist agent. It used to be used to numb pain and knock people out. It's actually quite dangerous, and we don't really use it for that anymore, for anesthesia. So just by moving that oxygen to the inside, we fundamentally change how it behaves. So, that's the whole idea of functional groups. How you put the atoms together completely changes how they interact with things. Ethers are ROR groups. And so when we want to name them, well, there's kind of two chains here, right? That gets a little difficult to figure out what to do, and so they kind of just didn't. There are very, very few ethers that we really use, and so for the most part, we just didn't give them a new naming system. We kept the old one. The way that worked, let's draw a few. I've got my methyl, so CH3OCH3. I can also have two carbons in a row. I can have one carbon and then two carbons. Like, there's a couple ways you can put stuff together. Well, the old nomenclature didn't use suffixes. Instead, it just used the functional group name. So these weren't dash anything. They were just ether. And then you would tell what was attached to the oxygen. And so in the old system, it was, hey, I have an oxygen acting as an ether. What's attached to it? Oh, a methyl and a methyl. So it was two methyls. It was a dimethyl ether. And if I've got an ethyl and an ethyl chain over here, well, this is a diethyl ether. So it treated the carbon chains as a subgroup of the ether oxygen, is how the old naming worked. Like I said, there's not a lot of ethers that are ever used, so we just kept it. There weren't enough names to make it worth adjusting. If you have a mix of functional group or carbon lengths, so an ethyl and a methyl, well, go alphabetical. This is an ethyl methyl ether. And there are no spaces. I know it kind of looks like I wrote one. Ethyl methyl ether. And so that is how you name ethers. And generally, if we use any, they'll be nice and short and small, easy ethers. There are a few other ones that come up. Isopropyls. So you might run into, like this. Old name for being attached to the middle of a propyl was isopropyl, and so this one is diisopropyl ether. And really, these are the majority of them. This is all we'll ever really see. So these four are kind of the ones to know, but that is where the naming comes from. They don't have a suffix. There's no suffix for ether. There is one thing that they do show up in other molecules. So say we had this alcohol on its own. 1, 2, 3, 4 carbons. This would be a butan-1-ol. Now it is possible to make situations where you have an ether that is a subgroup. That whole OCH3, and that's a CH3 up there. In this case, ethers are considered one of the least important functional groups, so alcohol immediately is the most important. This is still a butanol. It just has a subgroup. When you have ether subgroups, there is a way to describe them. And so we'd write our normal molecule first. 1, 2, 3, 4. Alcohol is our functional group. It is what we want to be the lowest possible. So it is a butanol still. It is a butan-1-ol. Out here at the 3 position is a methyl ether. We call that a methoxy. So if your ether is a subgroup, it does have a suffix. It is oxy. And so you would say, how long is my carbon chain? Oh, it's 1 carbon. So that is a 1 carbon ether subgroup. And so that then goes in front. It is a 3-methoxy butan-1-ol. And so ethers can be subgroups. In fact, let's try it with a different one. Let's make the aldehyde. And we'll go, and let's give it 2 carbons this time. If we do that, I have an ether subgroup, and it has 2 carbons on it. So this is an ethoxy. I have my main carbon chain. It is 1, 2, 3, 4 carbons long. My aldehyde's at position 1. And so this becomes a 3-ethoxy butan-1-al. And so ethers on their own don't have a new functional group suffix. But ethers as a subgroup are not uncommon in biology and chemistry and industry and things. And so they do show up as subgroups some of the time. And so really what we're learning here for ethers isn't so much the name for the ether group itself. Recognizing when they exist is important, that it is an R, 2 separate R groups attached to your oxygen. But the key new introduction for naming here is actually them as a subgroup. So much like a methyl or an ethyl or things like that, ethers can be subgroups as well. And we said we introduced this. If you're attached to the middle of 3 carbons, you are an isopropyl. You can have isopropyl as well. So we could have, let's do the aldehyde again. I could have O like that. And again, what I find, here's an oxygen that goes to a carbon and a carbon. Well, the subgroup is the oxygen and its other things. The main chain isn't part of it, so that O and the 3 carbons coming off it is the ether. We go 1, 2, 3, 4 again. This is a 3-isopropoxy. So isoprop was the name for being attached to the middle. Oxy for being ether, so eth-oxy, meth-oxy, isopropoxy, which you'll usually hear said isopropoxy, just the way we break it up in English. But isopropoxy, butan 1-al. And so that's the introduction to ethers. They are mostly going to be seen as subgroups attached to other things. So they are really an introduction of a new subgroup. Despite that they are their own functional group, they aren't all that practical or useful, and so they really didn't have a lot of unique regular ether naming. They only really come up because they get attached all over the place on other molecules to slightly change the functionality of that molecule. Alright, well thank you for watching the ether section.